So again, my name is Brian Connell. I'm the co-lead of NeuroHub along with JB Poulin. So we're just going to thank you for joining us for this next session. I hope everyone had a restful holiday break period as we get into the new year. So everyone should be able to see the agenda for the workshop today. As this was mentioned already, this is our next in the series of workshops that have been presented. Prior to this, we provided an introduction seminar in November, as well as a first foundations or fundamentals of NeuroHub training session, both of which are available online through the HPHL YouTube channel for people to look at. And it is assumed that most people or all people here should have gone through those sessions or have an existing familiarity with the platform to facilitate some of the background that you're going to be hearing about today. But just to begin, we're going to just give a couple, I would say, a couple of slide highlights of, an introduction to NeuroHub. I'll hand it to JB, and then I'll say a few more words. Then we'll jump right into some of the workshop logistics, and I'll hand it on to some of our team members here, and I'll introduce those as we get to that next phase. So JB, I'll just hand it to you, and I'll move to the next slide, and then I'll control the slides as we go from that.
Thanks, Brian. Hi, everyone. This is a pleasure to have you on road. You'll be better on in person, but hopefully, before the end of the year, we'll have that as well. I just want to say, not taking much time from the workshop. I just want to say a couple of words on the philosophy of NeuroHub. First of all, one of the key things is that NeuroHub is an integrative platform where you'll find different pieces useful for different aspects of your work, hopefully. And that integrates platforms such as CBrain, Loris, the Jupyter Hub that would be demonstrated today, the CNP datasets. And so it's really an ecosystem. And I would say also for a wide range of users. So not everyone will be using everything, but hopefully it's like a buffet. You will find, plates and dishes that you like in what is proposed. And conceptually, it integrates four spaces. I would say your project portal or dashboard aspect, data sets, of course, which are the fundamental of what we're doing, data science, integrative computing environment, which is implemented with the Jupyter Hub that you will see, and the processing factory that is implemented by CBrain. You will be seeing that as well. And next slide, Brian, please. So if you go, if you take this overall picture of what is proposed by NeuroHub, you see that most of it we're trying to first of all implement standards, and that's why you're logging in the platform using your ORCID, or you can log in with using your ORCID. And also providing a lot of data sets, the CONP data sets, but most and foremost the UK Biobank data set. There's a huge and really fundamental data set for what we're doing. Can be also used for not only in itself, but for comparing with a smaller data set you may have elsewhere. We have a number of flexible way of including data, including the things that are in Loris, the things that are in OSF, and there's a backend, data lab backend that can be used as well, or Zenodo. And the heart of NeuroHub is really, I think, I would say, on the capacity to process and to investigate data. And that's mostly implemented with the CBrain, but you can also use the compute data directly on the dataset of NeuroHub datasets. And I think that's it. Brian, you just, the only last thing I would want to say is that in the future, we really would like to make sure that all that work, computational work, can be directly published in actual publication, in actual the research objects publication. And I think that's really the direction that I would like to see that project, because the work that you're doing using that platform is really the academic work. I mean, the writing of the paper is I would say the narrative of it, but the actual work is there, and that is what should be published and possibly reviewed. Thank you, and enjoy the workshop.
Thanks, JB. Sorry, I was just clicking between windows and it automatically transferred to the next slide. So thanks for the introduction. So let me just take control and move back here. So as to follow up on what JB said, really it is an ecosystem of spaces, and really the intention is to, with this ecosystem of tools available to help you facilitate your daily work through your, the life cycle that we normally see when we look at scientific analysis. You're going through one form of data collection or data acquisition. You're going to do some forms of processing on that data. Then you're going to want to look at that output, that derived data, to do an analysis on that. And then afterwards, after various iterations, because this is not just a singular loop that one goes through data, you're going to be looking at some form of sharing or publishing, whether it's in publishing with your colleagues and with your peers, but also likely within the more, I'd say, the traditional, publication context. So the idea is within this tool space to provide mechanisms to facilitate that activity. So within NeuroHub, as we've had it now, and this was explained during the information sessions that were given before Christmas, we have a web-based user interface that provides basically a portal view into both the data management and collaboration side, but also into the orchestration for large-scale processing. And within that large-scale data processing, we have a number of tools already, and we keep adding more tools within it, leveraging CBrain orchestration in the back end. And from the data management side, it can scale, ranging from large-scale data sets that we operate and provide, such as the UK Biobank, which some of you may already be using in various forms, other data sets that are of interest to the neuroscience community, such as those visible through CMP, or even ones that are just specific to individual research groups. The capabilities for handling those data are present within NeuroHub from the ground up. And of course, one of the things that you'll particularly get experience with today is the interactive computing capabilities that are provided through the interfaces that we have within JupyterHub through specifically the CBrain API. So without too much further ado, this is kind of like the guiding ideas of what the objectives that you'll be going through today in the various exercises is learning to use NeuroHub specifically in the context of what power is brought to you by the CBrain API and in conjunction with the JupyterHub interface, the JupyterHub notebooks. So you're going to get experience with doing exercises specific to sessions, files, dealing with groups, what are concepts of called data providers, which you should be already familiar with based upon your prior experience using NeuroHub or the prior training. And then you'll get a view into some of the applications, an example that'll bring you through that using JupyterHub notebooks from the application side. And as time allows, into some other elements related to launching tools and tasks, again, through the JupyterHub interface using the CBrain API. So that's, I would say, the high-level learning objectives for today. Now, just to say a few words about logistics, because obviously, as JB indicated, we prefer to have been in person, but we know the circumstances are such that it's not feasible. So just, you probably have heard these already in your various other Zoom sessions. We just ask that people keep their microphones muted unless they're speaking. And just to help facilitate, since we have accounts that were created for all the participants to know who each and every person is, we can try and help out. If you can just make sure you adjust your participant name to your first name, last name, so that we can have a easier identification. As I've already mentioned before, for those who may have come in partway through the beginning, this workshop is being recorded and portions will be edited and shared online afterwards for those for further reference to yourselves, as well as for maybe any of your colleagues who were not able to attend. But really the key thing here that we want to emphasize is the exercises, and then you'll see that as being the core for the workshop today. Of course, logistically, you can say, okay, well, it's hard to raise your hand in a normal room, but it's easier for me to raise your hand in a normal room to get attention of one of our helpers. You should see in the participant list the people who have helpers beside their names. Those are people from the NeuroHub team who will be able to address any of your questions or any of your issues. But you can address it collectively, all of us, in the chat window, indicating that you have a question. The presenter can then ask you to unmute and speak your question if it's something you want to verbalize, or more simply, depending on the nature of the question you have, you can type it just directly within the chat window. Particularly as we go through the exercises, some of these things we can't necessarily just resolve by answering a simple question, but if we will try to do so. But if you do need particular help, or if you're stuck in a particular element of the exercise, raise your hand using the Zoom feature for raising your hand, and one of our helper team will message you. Sometimes it may need involving going into one of the breakout rooms that are present, in which case then they can go in and join you, and then you can share your screen, and then we can maybe get into some more details of that information exchange to try and help you out. So nothing's been pre-assigned in breakout rooms other than just using those as kind of as drop-in spaces for those more direct communications that need to happen. Otherwise, you will also see throughout the course of the afternoon here, there'll be various checkpoints that the leaders will be carrying you through, and they'll be asking you to say, is everyone up to this particular point? Is anybody having issues, or does anyone completed up the step? So when prompted, use the features that are available within the Zoom space to mark with a checkbox or a no if you indicate just where things are at. So that way it can give a visual representation to the person leading the session or leading the exercise that you're making progress, or there's some things that we need to help out and bring you back in. And lastly, we'll talk about accounts. Before I do that, though, I will let actually one of our team members, Darcy Cannell, take over this particular piece here. So there'll be two sets of accounts that you'll be using, one for the NeuroHub interface and one for the JupyterHub side. Darcy, if you want to take over, I'll let you explain this part, because I think this naturally transitions into the first exercise and the first piece that you'll be doing. And I don't know if you want to take control of the screen, or do you want me to, I can just tab the slides.
I'll share screen.
Okay, I'll stop the share then and hand it over to you. So while we do that, just introduce Darcy Cornell is one of our developer analyst members of the NeuroHub team. He'll be carrying you through 3 of the 4 exercises today. And also on the line, we also have Jacob Sands Robinson, who's also helping out and has kindly provided his time, and you can see him waving. He's exercising Zoom at a good distance to provide his leadership for showing that exercise today that he'll be showing this afternoon. And he's a graduate student who's very versed in this, and they'll be helping you along as well. So it should be over to you now, Darcy.
So, hello.
Including, just keep in mind that also the slide deck you'll probably have to show in addition to the screen that you have, right?
I will, yeah. I'll go back and forth.
Okay, perfect.
Between this page, and I hope everybody sees it, this page, and it's big enough for everyone. And first we're going to talk about the NeuroHub portal. Well, a good and happy new year, first of all. I have my own login to NeuroHub and CBrain, but you guys will have to look at this table and see your initials. So your username is going to be one of train _ a number, then your initials. So find your initials in here. And I hope everybody can find their initials in here. And you're going to use as password this password. So let's go back to the NeuroHub. And I'm just going to use my username. I'm not going to use one of these train usernames. I'm going to use mine. And I'm going to use my password. And signing in, you should get, you should get this home screen. Now, you won't have all of this stuff up and about, but if you guys can log in using your new username and this password, the username.
Not that one, not that password.
Sorry?
The one at the very top.
Oh, I'm sorry. Thank you very much.
Yeah.
If you can find your username here in the table and use this password on the NeuroHub page. And I guess what we're going to do is we're going to wait for all of you to do that, to log in. And when you do log in, if you could all put your hands up when you have done that, please.
Darcy, do you mind putting the password in the chat window?
Okay, that's a good.
But people will just need to keep in mind that they'll have to replace the 2 capitalized N's with their particular number and the AB with their particular initials portion.
Exactly.
I would like to add one more thing. For any of you who already have a CBrain or NeuroHub account, you are absolutely free to use your real CBrain or NeuroHub account instead of the training accounts if you want. We've matched the list of registration for this workshop to the list of current CBrain and NeuroHub users, and we've added the existing accounts to the projects that will be used for this training session. So it's up to you guys. For those who already have an account, you can also use your existing account.
Yeah, and that's a very simplified way of helping it, yes.
Exactly. Thank you, Pierre. And that was the voice of Pierre, which hopefully you'll be hearing a lot about. We'll be interjecting now and again when I say something completely incorrect about how NeuroHub and CBrain work. So I see a lot of hands up there. I can't really count them on this. Is that a majority of people who are hands upping? Is that everyone who's hands upping? Can somebody go through the...
I see a large number. I don't see everyone, but I see a large number.
There's still about 15.
There's still some to go, yeah.
Okay, let's wait a little bit. Again, I gave you in the chat, I gave an example of user train_01_AG as username with password train01AG-B7 is one of the users. Don't use that if you don't have those initials, please. Don't use just a random one. Please do use that 01AG only if you have the initials AG. Okay? So you should all have separate logins here on the NeuroHub, and you should all be seeing NeuroHub dashboard. But you will not be seeing the exact same thing as I do online, like latest tasks and latest uploaded files.
So I still see a bunch of people without their hands. If you're having an issue, if you can change your hand up to the different symbol, we can then know there's an issue or not.
Yes, please, if you could.
So I still see 1, 2, 3, 4, 5, 6, 7 so people. And that's dropping now, which is good.
So while I'm in presentation mode here, while I'm in share mode, I don't have as good a listing of the participants as I would if I were in the other mode. So it takes me a while to go through the
raised hands at the moment, just so you know, Darcy. So.
So for
okay, thank you, Robert.
Logged in. So if anyone is having problems, could instead of hands up, is there another way to signal that you?
Well, they can just please write in the chat window if you're unable to log in. Just say if you're not able to log in.
Of course.
Please type so in the chat window.
Of course.
And we have already seen Robert's message.
Yep.
And we still have Raul, Pascal, Mingli, George, and Douglas to give some feedback. The hands option should be there now. I've seen this happen in Zoom before, where sometimes the different options for presenting some hand disappears. I don't know why that's the case.
Yeah, it does. And so
let's move to the next one. So yes, I didn't even know Zoom worked through. Okay.
Okay, let's go to the next one. So
let's go to the next one. Step 1.
And that was where am I? Sorry. Yes, this is step 1. So what I'm going to show next is new share. You should also have, so when you you should have the link for NeuroHub Calcul Québec Cloud. And I will put that in chat.
It's in the slide deck, Darcy.
It's in the slide deck? Okay.
Yes.
And that should redirect you to https://jupyter.neurohub Calcul Québec Cloud Hub login. Okay. You're going to use the username is going to be user, then 2 digits. And again, it's the 2 digits from the that were in your train username. Train underscore.
No, or the user. Sorry, yes. Go ahead. My mistake.
Yes.
Sorry to interrupt.
So for me, it's user 50. For train_01 underscore AG, it's going to be user 01. Okay? But me, I'm user 50. And I'm going to use the other password, the one that I initially said to use, but now we can actually use it, is the one on the bottom of that logistics page, workshop logistics page. And don't put anything for OTP. Okay, so user 50 is me, the password at the bottom of the logistics page. Sign in. No, let's not. We're going to have to wait just a little bit. And why did it automatically? Because I'm already logged in somewhere else. Okay, so I'm already logged in somewhere else and I haven't logged out. That's why it brought me into this. But you guys should see another page and there should be a few options. The only option that you're going to change is the amount. Somewhere around here on the page that I should be showing you should say time hours. You're going to put that to let's say 3 hours. Okay? So that your session lasts for 3 hours. Okay? And then press, what is it that shows up? Is it start? Is it, I don't remember now. I'm sorry, I really thought this would show up for me, the page that you should have too. But can anybody confirm that they're seeing the page after putting in user whatever, user 21, user whatever, and putting in this password, that they're seeing an intermediate screen where you have to put in time. Did everybody see that? Yes, okay, good. So, yes, server options. So just the only thing is to set the time hours to 3 hours, to 3. Then press the start button. So once you press the start button, you should see this. Is everybody seeing that? Again, put your hands up if you have reached this page that I am showing now. And it should look, well, actually, you should arrive there. And it should look like this. And yes, the spawn may take a while. After that server options, when you say launch server or whatever, it actually may take a while to spawn this page that you get to. That's completely normal, because what it's doing is right now it's provisioning within a test cluster. It's assigning you to a core within that test cluster. So again, go to NeuroHub Calcul Québec, and put in user, no underscore, the number that you used, this number here that you used, okay, from the table. And then all of you use the same password. There's no changes to the password. I didn't make a specific password for all of you. It's all of you have the exact same one. The only thing that's unique to you in the Jupyter Lab context, as opposed to the NeuroHub context, is the username user NN. Okay, so please use the number that's associated with you that was in the table that you found, where you found your initials. So that we all are using different. We all are using different accounts on Jupyter Hub, user whatever, and we're all using different accounts on NeuroHub. So who has a good number of people have a hand up. That means you've gone through it. For those who haven't, could you please say in the chat? You don't see.
Darcy, can you go back to the trainings piece, the slide with the contains?
Yeah.
So people can look that up. There's some people who need to double check, please.
I think this is yours, Train 59. And you shouldn't see it may take a while to spawn, but there should be like a spawning or a working or a something ing. So some of you are seeing some of you seeing a blank screen and not seeing this, or not seeing the screen that was before this that I can't show, that that has server options on them, where you're supposed to put in 3 hours reservation. You cannot use so if you're logging into NeuroHub, use your regular NeuroHub /cbrain. On Jupyter Hub, on Jupyter Lab, you cannot use your normal. It's a completely different accounting system.
It's a different system, JB, so that everyone can use their NeuroHub account on the NeuroHub portal, but the Jupyter Hub is specifically set up for the purposes of the training. That way other people can use their Jupyter Hub interfaces wherever they want later. But it's a separate instance, so that's why there's no correspondence from the names, other than the NN value. So I hope that's clear.
I just wanted to point that out, that this is a completely, for the moment, completely different system, and that's going to be, like possibly linked in the future.
And the reason for that is, at least on the Jupyter Lab side, this is a contained training environment just for you guys on Compute Canada hardware, not using regular Compute Canada logins or anything. This is purpose-built just for you and just for this training right now, is what you're logging into on Jupyter Lab.
And the purpose of this is really so that there are already multiple instances. There's already, for example, Compute Canada, there's the Beluga instance of Jupyter Hub. There's also Syzygy, which is available to academic institutional members in Canada. And there's also the ability to run individuals. So we wanted to have a common platform for the training. But as JB said, yes, there'll be other options of linking in the future. But for the purpose of the workshop, we have a dedicated platform of Jupyter Hub.
So if that's good to see, Usher, is anyone using 59? So yes, 59 is, let's go back. 59 is Yasher. You can use 60. You can use user 60. Did I not assign you one of
Follow
the...
up separately offline, JB. We can give you a separate one.
That's okay. I just, no worries.
Oh, you assigned 60 to Christine. Then I don't know.
That's okay. Go on, Darcy.
Okay. Okay. So I hope those who don't have their hand up are in a good place. Or I don't know. I think I'm just going to go on with this, even though not everyone has a hand up as being logged into Jupyter Lab. If you can't,
I think let's say, Douglas, are you okay? Because I know you said you couldn't raise your hand before. So
yes, I'm okay. Yeah.
Okay, perfect.
Okay. Good. Let's go forward. And I think that during the break, when we have a break in, I don't know, about an hour, let's revisit this, because I don't want to leave any of you behind. And in fact, if you do have problems, even while I'm talking here, please do either. So now do talk in the chat, and hopefully one of the helpers will be able to talk to you. I don't know if I'm going to be able to see you in chat as I'm doing my own chatting around here. I may not see you. Sorry about that, but hopefully somebody will, and somebody will be able to help you. So hands down, everybody seems to be.
That's why we have helpers. So Darcy, you go ahead, and if there's things that we see, we have a number of eyes already watching the participants list.
Okay, cool. Thank you. So last time, I guess for those, wrong one. For those who have taken the training from, I think last year, very late last year, I think Verena took you through a lot of what's happening in the NeuroHub website, web experience. And that's all well and good for looking at status, for starting a job here and there. But what we're going to do is try and automate doing a lot of things with NeuroHub, okay? And the way we can do that is with scripts rather than with the web UI. And actually, before I get into that, before I further motivate why we're doing this, let's just look at this Jupyter Lab instance. I don't know if you have used Jupyter Notebooks or Jupyter Lab or Jupyter Hub or any of those options at all. But let's just get acquainted a little bit with this website here, with this web app here, the way that you may know this web app, the NeuroHub one. So notice that it comes up right into a file view. And this file view is your home directory. And here it's your home directory on this virtual cluster that I've made for this training. But if you log into Jupyter, let's say on Beluga, the Beluga Jupyter Hub, which is a little bit flaky right now. I think it may actually be down right now, to tell you the truth. Last status message I saw on it, so don't try it right now. But the file system that you'll see is your Compute Canada file system. If I were logging in directly to Compute Canada, so you'd see your projects that you're associated with, the Scratch, everything is there. This one is just open tabs and open terminals, and we'll see that a bit later. I don't have any table of contents stuff. So one of the great things about Jupyter Lab and Jupyter Lab on Beluga and Jupyter Lab here in this test environment is that you have access to all the Compute Canada software stack. So I can load, let's say, the SciPy stack, and I actually don't remember which SciPy stack I should be using right now. In the Compute Canada docs, this is all documented somewhere, or at least should be documented somewhere, which SciPy stack to use. And that loads just a ton of stuff. We're not going to do that right now because we're only using a small portion of that. But SciPy, the stack at least, loads, oh goodness, what does it load? It loads NumPy, it loads, I don't remember all what's in it, but it's a lot of stuff. The Compute Canada software stack module system, I should say, is really quite good and really quite useful. And this is one of the main reasons to use use this here. Another thing, so if you go on extension managers, here I have extensions enabled. What you should see is a warning saying, would you like to enable or disable it? Might as well enable it. No problems there. But this is, so I've got it enabled. And here again, you should see a button that asks you to enable it. What's enabled by default is this LMOD, the CC, the Compute Canada module system. This is in fact this extension, this Jupyter Lab-LMOD, Jupyter Lab extension. And there's any number of other extensions that you may be used to if you're used to Jupyter Lab, okay? And lots of nice ones where you can work directly with LaTeX and GitHub, and just a ton of extensions that work specifically within a Jupyter Lab notebook. Now, we haven't gotten to the notebook part yet, but give me a second. So, this is, poke around, look around. It's a nice environment. It's good. There's lots of stuff happening in it. I like it. So one of the things that we have in this virtual environment are we can launch Python notebooks, Python console, which we don't use so much, and terminal, which we do use. So here, if I'm looking at terminal, I can look around, and I can do anything in that terminal. It's as if I'm SSHing into my account on a Compute Canada resource. But here you're SSHing in a tab to a resource within a virtual cluster with your username, with your particular username. So here you should see user blah, and I don't know what node it's going to assign you to, but it'll assign you to one of node 1 through node 30, I think, because each of those have 2 cores. So we should be okay. If you have a problem with being assigned to, if after you've spawned this, you're getting glitchy or you're not getting good performance, please do bring that up, and we'll look at that. But this is one of the good things too, is just you've already got SSH. You don't have to do SSH from your terminal. So on to the specifics for NeuroHub. All that said and all that gone through is in your file view, again, your file view here on the side, you should have a NeuroHub examples, okay? And let's just make that a little bit bigger. We're going to go through notebooks 1, 2, 3, and hopefully 4. Okay? So let's all just start up, double click on NeuroHub Sessions and Files 1. So has everybody double clicked on that? And does everybody see what I see? And more importantly, does everybody see a green dot there? If you see the green dot, that means that this is running. This is running in a, this notebook is running in a session. Okay? So I hope everybody sees that. And here at the start of this notebook, at least, I've got some explanatory text about where are you running this? Are you running this on Beluga's Jupyter Hub, which I intimated to? So let's actually go look at that. Here it doesn't have OTP, and so it's Jupyter Hub, Beluga, Compute Canada. When it's up, when it's running, and if you have Compute Canada resources, what you should get is an environment exactly like this, okay, that you can run things on with a couple of extra provisos that I try and put into here, is that into the yes, exactly. Thank you. That's in the next block. Thank you, Gabriel, though. I saw that, and you're exactly right. So, wait, what was I going to say? We will be doing token, but I do want to show you username, password quickly, just so that we reinforce that there's a couple of ways of getting to this. So here, don't worry about these because we're running it within our cluster, right? We're running it within our virtual cluster. So in a notebook, here in a Python notebook context, you're going to click on this and do Shift Return. And what you're going to see is now it's going to execute. We're actually getting to executing things. So we're actually executing install requests, okay? The requests library. I hope everybody is seeing that. Again, what I did here is I just did a Shift Return, or you could do run the selected cells, use the little run play thing. Module not found after install. Oh, okay, because we're not there yet. We're not at this. Wait 2 seconds. So I just want to make sure everybody has this and is seeing this. But that's Gabriel, that's a good error. Yes, he is, but it's a good error because I actually wasn't going to go through that error, but let's actually do that and get that error, okay? Shift Return. So what happened here? What happens to get this error? Well, I've installed requests in the context that this Python notebook is running. But the Python notebook does not know about that context update yet. So in fact, what I have to do after I do that pip install is this little restart the kernel. Restart, yes. Ask for it to restart. Okay. And now when I run this, yay, it's important. So it's restart kernel, then run this second cell. Okay, and we all know how to run the cell again. Remember, it's press play or do Shift Return or Shift Enter. Okay, so JSON is all and getPass are already in the standard library. So here, what's this thing about the base URL? Well, NeuroHub has how do you do restart kernel? It's this little restart button, this teeny restart button at the top of the tab. Okay? No problem. So base URL, NeuroHub uses as its underlying technology, underlying system, something that's been around for a while, that Pierre and Natasha have been working on for a long time and is a proven technology. It's really good. And that's CBrain. And so really the NeuroHub API is the CBrain API. And so let's go look at the CBrain API description. And actually I've got that there, but, and we're going to be using it raw. We're just going to be doing HTTP requests, that is get, put, post, against this, against the what do you call this type of this type of REST API? Thank you. So this is a REST API, and we're just going to be going directly to it, going directly to these URLs to use as an API. We're not going to be using some library that does a lot of niceties for us, because I want you to see kind of the bones and the sinew of what's happening when you do a request to these to this REST API. So that's why I'm saying base URL. Every request that we do will be with respect to this, and we're going to add on little things like with session. We're going to add on, are we going to get session? Are we going to post session? Are we going to do that? Anyways, all of this is documented here, documented well here with some examples. If you look, again, if you go here, there's examples, let's just say. So let's go in and let's actually do something now. So all that we've done so far, me and all my talking so far, has just set us up to actually do stuff, to actually talk to anything. We haven't actually done anything. So 1B, there's two 1Bs. Yeah, that I did not do a good job naming those. So yeah, don't look at 1B and 1B. Let's just look at the first 1B. You cannot do the first 1B, but let's just go through it just so you know what's happening here. So I'm going to get username and password from within this notebook. I'm going to pass those credentials to a request and post that to the base URL plus session. Again, let's go back and let's look at what the post does. That's create a new session. Okay, so we're creating a new session here with this, and then we're just doing some if there's looking to see if there's an error. If the login is successful, let's get some session info and let's get our user ID. So let's run this. And you'll see a little username come up, and I'll just put in my username and don't look at my copy and my password. So I'm saying if you want to follow along with this cell, do so. If you don't want to, don't worry, because we're actually going to be connecting with the API token next. Because this entering username password, especially when you're automating, right? Especially when you're doing something. I want to write a script. I want to write something that goes and looks at all of these files and submits all of these tasks and does blah 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 blah, right? Just having it stop in the middle and say, please enter username password is icky. So what we're going to do, the second 1B, what should be really 1B, because that really should be 1A, that's me not numbering correctly, is let's go back to our NeuroHub dashboard. Remember our NeuroHub, right? So let's go back to our NeuroHub dashboard and go to My Account, okay? And you're going to see a whole bunch of other information, but what we really want here is new API token. So again, we're on the NeuroHub portal. I've gone to My Account, and I'm going to say new API token. Now, don't look at my API token and don't use my API token. You should be looking at your own API token, which is this long series of numbers and digits, or same thing, numbers and letters. So digits and letters, and doing a copy of that. Okay, does everybody see their own API token here? I hope everybody does, right? So again, this is on NeuroHub, My Account, new API token, okay? Now, what I'm going to do is in here, I've copied that long string, and I'm going to paste it here. Again, don't use mine. Don't copy mine. Copy and use yours. Well, it's hard for you to copy and use mine off the screen because it's so long. But it's much easier to use yours. So you're going to be using this API token instead of username password. Okay? Now, let's run this. Session is valid, and user ID, again, is 1308. So a note here, however you log in, and however many times you refresh, and you may refresh that API token to get a new API token, your user ID should always be the same number. Okay? Should always be the same number. Mine is 1308. Yeah. Yours should be, I don't know what yours is, but I'm sure it's something wonderful, something completely appropriate for you. So has everybody gotten to this place where they've got a session valid, user ID 1308, and either through this or through this, but really hopefully through this, because we want to set CBrain API token to something for subsequent things. Okay. User ID 2631 is a perfectly crumpulous user ID. Yes, and as Piat is saying, I'm doing this raw. I'm doing this requesting a post directly to a URL with data params and headers, so that to show that you can do this on the command line with curl. Even this is almost at the level of doing this with curl. It's the exact same mechanics and the exact same data that you're going to give to curl on the command line if you want to do this. Or in fact, if you want to use an HTTP library in some other language or some other context. So let's say you've got an R RStudio. I don't know what the HTTP library is, but you could do something exactly like this, and you should get the exact same results. Okay. So who is anybody getting session not valid at this point? Anyone? Not seeing any hand. I'm not seeing anybody saying
Louis Collins did. I'm not sure if he actually got a session not valid, or whether he's just asking about it. So maybe Louis, if you actually did get a session not valid, say so. And if you were just curious, then we can dive into those details.
No, I ran it. I put in the API token. I ran the script and got nothing out. No output, as if it didn't run.
Out of this cell here, you've got nothing. Is it? So has it completed, or is there a little star there? Is there a little asterisk?
There's a star.
So it's still working. As long as there's an asterisk next to the cell, and it hasn't put a number in there to say the number says it's completed, and it's the fourth thing that we've done so far in this session since restarting the session. So the first thing I've done is that, second is that, third is that, fourth is that. Things that are still working is star. So you shouldn't see that for too long. I mean, I'm not sure if the CBrain API that underlines the NeuroHub is slow right now. I don't think it is.
Okay, can I just restart everything and start from the top?
You can please restart the kernel with the little restart thing and go back, do the import, then do the API token. So do this cell import, then this cell with CBrain API, if you want to restart. Okay. Oh yes, thank you for reminding me, Sepke. Also run base URL. So there's 3 cells that you have to run if you're restarting. The base URL and the CBrain API token one.
So that all works for me. Restart and then rerun the 3 cells. Everything's good. Thank you.
Yay! So yeah, remember, we're working with networked resources. Sometimes this request will just go bang in the middle of the night, and who knows why. So getting to a remote resource is always like that. So next is this. Hopefully this won't be long running for you, but I'm going to start mine right now because this is going to be very long running for me. So what this does is we already have a session set up, okay? We already have session info set. This for the session that we're in, okay? And it has in it our user ID, this, and the API token that we furnished here. So these values we can take from session info, and we can assign to user ID and to CBrain API token once again. So here I'm resetting CBrain API token to what has been returned to us, which should be the same CBrain API token as this. Now you'll notice this is still running for me. This says asterisk, because what I'm asking it here is to build up a list of files that I have access to, okay? And because I'm in a number of groups or projects, I have a large amount of files that are in all of those groups or projects. Okay, so what I'm asking here is I'm saying get to the base URL user files, and what I'm giving to it for data is this is a paged request where I get pages of results up to 1,000 for each page. And I'm going to increment the page and ask again for page 2 with per page 1,000. And because why is it paged? Because there may be a ton of files. And the return result may be the return to JSON may have too many entries. It may have thousands and thousands of entries. So here we're limiting each ask to the API. Please only give me 1,000 per page. So so here, while true, I'm requesting if there's a problem with the return code, I break. If there isn't, I increase the page by 1. If though the number of results I get back is fewer than I asked for, then I know I'm at the end of my string of page requests. Okay, and I break out. So I only break if there's an error or if I think I'm at the end. Okay, and I hope. So this is looping, right? So you're getting a files request. So who else is seeing a request fail? Same. Everybody is getting one.
But are they
Okay.
expecting files? If they are they using their account? Are they expecting to see files? Just maybe clarify the answer to people with the test accounts.
You should, yes, because you're part of a. You're
exactly.
Part of a. Sorry.
Exactly. Just so clarify that for them that they should expect a non-zero result.
You should get a non-zero result because you are part of.
Can I say something?
Yes,
go ahead, Pierre.
I have an explanation. It's possible these are brand new training account requests, training accounts. And so if you've not switched to CBrain at least one and agreed to all the license agreements, then all the requests are being, blocked and redirected saying, you've not signed the CBrain license agreement. So basically, maybe we should just ask everybody to just switch to CBrain. There'll be 3 pages where you have to agree on the agreements, check boxes that you have to agree with. You cannot show this, Darcy, because you have already done it. But basically, show that you can click on the CB in the corner there. If you're using the training account, it's very likely that this is the reason. It's because the license agreements have not been agreed to, so the API is kind of blocked from providing the information that you guys are trying to fetch.
Oh, thank you, Pierre. I didn't even...
That's just a hypothesis. I'm not sure, but I think is what's happening.
Is anybody in going to the NeuroHub portal and pressing the CB? People are saying, yes, it works now. So pressing that CB in the top left, are you seeing you won't see it on my screen because I've already agreed to everything. Are you all seeing the please agree to this on the NeuroHub portal when switching to CBrain? Looks like a lot of you are.
I would like to apologize. When I set up those training accounts, I forgot I wanted to automatically have all the training accounts, having signed those license agreements, to record that they're signed. But I forgot to do this.
No, that's actually a good error because it shows us that remember that the code and the data in NeuroHub and in the underlying C-brain may have attached with them all different kinds of licenses, or these aren't just for open data sets and open code, that there's a variety of licensing, and that sometimes you just have to go through and you have to agree to the licensing that's associated with some data and some things. And that's a feature of NeuroHub and C-brain. It's a good error, at least from my perspective. Okay?
I agree with you, Darcy. Can you repeat the C-brain user license questions? Can you go through that one more time?
Sure. So when trying to access your user files, you may get a weird error. It's because you can't get to them because you haven't agreed to the licenses. And the way to agree to the licenses is go back to your portal neurohub.ca, then go to CB in the corner, and you'll get to the underlying C-brain view of NeuroHub, of the NeuroHub project and NeuroHub spaces. And after you've done that, you should automatically get something asking you to please accept the licenses. I can't show you that because I've already accepted the licenses.
Yeah, Pierre can repeat that if it needs to be clarified to people what it should look like.
It is basically just 3 forms, one after the other, that has a bunch of text, and there are check boxes at the bottom. You have to click the check boxes and click a button that says, yes, I agree. You'll have 3 of them to agree to. And most users have already done this at this point. And yes,
I think a lot of you have.
576 files.
Yep, that should be right. So me, unfortunately, it's still running. See the asterisk? It's still running because, too many. So, anybody still having problems? Anybody having problems with accessing their user files? Anybody haven't gotten 576 with the training account? Or anybody stuck like me, just using their regular? Nope, we're gonna filter ourselves just using Python. So yeah. So unfortunately, now what's documented in the API is just the ability to get all user files. And you'll see that for me, that is a very bad idea. For you guys, it should be fine. And now if you guys want to go along while I'm waiting, and I think I'm going to have to be waiting, I don't remember how long I have to wait. I should have timed this before and actually seen. Or actually, if I want to just stop this, yeah, it's not a great idea to list all the files. But once you have it at the beginning of a session, at least if you're writing a script for a long-lasting session where you're going to be doing a lot of stuff, this is just, this is regular setup overhead, is getting all these files, right? Especially if you're going to be working over a lot of stuff. If you're going to be working over all of them, if you're going to be slicing and dicing, this is just regular, right? So here, what I can do is I can actually stop, and it's stopped. And I am going to say, if, instead of this, I'm going to say if files underscore request page is larger than, let's say I get 100 pages. Let's see what happens. Actually, I'm just going to get 100 pages, and I'm not going to stop when it's the end. I'm just going to stop after 100 pages. I'm going to break. Okay? Let us try that. See what happens. 100 pages should be fine. Should work. Should come back soon, I think. I really don't remember how long this takes. Okay, taking a bit too long. So let us do 10 and just see what happens. This really shouldn't take a long time. This should come back right away. Should be quick as a button. Okay, while I'm saying that, this really should come back relatively soon now that I've done that. You guys can go on to filter files. What we're going to do is, with that list of files we have, okay, let's look for, there we go, 10 times 1,000, it's exactly, so 10,000. So it did come back for me, did do something. So with these 10,000 files, let's actually slice and dice it ourselves. Let's look through that list of files, that big blob of JSON we have, okay, and look for something whose name includes Nifty, right? Let's see what happens. 0 filtered results for me because I didn't go far enough. Okay? But you guys should see something. I hope you're seeing not 0. Has everybody done this filter results and seen 2? Okay. So let us do ba-dump. And what do I do here? Filter results 0. Because I don't have filter results. Okay. So you should be able to run filter results and actually see something. Okay. And you should be able to run this. And actually, what I'm going to cheat here. I'm going to completely cheat. So don't look at me while I cheat here. But I'm going to go to projects, workshop Jan 2020. Okay. Well, actually, do look at this because this is useful. The interplay between the portal and the API interesting in this case. So the input that I really want is this file right here. Okay, so let's look at this file. So this file should be one of the two that come up. Okay, and in fact, if I look at the URL, this is the file ID. So in fact, if I copy this file ID and I go back here and I say, let's forget about that, and let's put in the file ID that I got through hook and through crook. I didn't, let's do, oh no, stop this. Stop this one, and do this. File, what do I do? File info. No. Ah, okay, nope. Ignore what I did with that cell. I meant to put that here in the next section. So again, through hook or through crook, we're going to get that file ID. Okay, either by listing it, by filtering it, by slicing and dicing here in the previous section, or by going to the NeuroHub and just stealing it from there. Stealing that number from there. We're going to get it somehow. And here, let's run this. This should work wonderfully. And it does. Okay, now I'm getting information about a specific file. So I'm getting, relative to the base URL, user files, the file ID that I've got here that I got through illicit means, as opposed to through the API, through this means. And now I have information about this file. So this is the information that's returned that you don't have to look at and understand right now. But the user ID that put it there, its size in, is it sizes in bytes? I don't remember what its size is in. What type it is, it's an empty file. Yeah, that's great. What group it's part of, the NeuroHub workshop group, what data provider it's on. And we're going to get into data groups and data providers a bit later. But now what I want to do is, let's get that file. And I hope everybody is actually following along here in 2D, can get to this cell in 2D. Can everybody get there? And transfer encoding, yes, it looks like we've got a bunch of yeses that have gotten to there. And maybe some of you have actually gone ahead of me. Okay. So you should see this. So I want to ask you all, what did I forget here? What did I forget to put here? I didn't, oh yes, right here in 2C, I put in where it says in your notebook, paste file ID here, I pasted the file ID instead of getting it programmatically from the API. Okay, I could have gotten that file ID programmatically and put that in, well, in file ID. but I did not. I just put it there. Okay, and we got this information. Now we're getting the information. Now, I wanted to ask what it is that we are, and where did I get that file number from? Well, I would have gotten it from here if this had returned everything that I wanted, but I forgot how long it took. But where I got it from was the URL. So the URLs within the app correspond very closely, if not exactly, to the URLs that we're using in the API. So there's a correspondence, and there's a natural way of looking. If you want some sanity check, go look at the equivalent thing on NeuroHub, the equivalent to what you're asking for here. So the question I'm asking here, what did I forget? Well, I didn't do any error checking. So a nice API framework or library would do this for you. But really, I really should have checked the status code. What else should I have checked? Yeah, I should have checked the status code to see that we got something back that's okay. But I didn't. I just went fast and loose with the truth and assumed that I would get a response. Okay. Now, process data. Let's look at this. So 2E, I hope everybody can run 2E and gets the exact same number for both of those. Okay? So 1 is the length of the file that I just downloaded. The other is the reported size in the header here, is this. That I got from asking about the file info for this. Okay, does everybody see that? So, who could not get to 2E? Anybody that could not get to 2E? I know that last bit was a little convoluted because of what I could show, because of my slowness here on this end. You couldn't get there. Okay. Hussein, what happened? Where did you get, where did you get an error?
So the error that I got, it says, trace back most recent code last IPython -input -9. It's like, it says name file is not defined. Name file context is not defined, yeah.
Sorry, the what context isn't defined?
File content. So name, between two quotation mark, file content is not defined.
Did you run this? Because this should set file content.
Okay, probably I didn't run it. I think I run that. Yeah, now it's well. Now it's
Yay!
Yeah, thank you.
Good.
And maybe Darcy, just to clarify this question, but when we talk about the 2D part, he says get file contents. This is not retrieving the file to the local space, right?
So
just to clarify, just that people might think they're getting the file, but they're getting it, but they're not getting it they're getting in a certain context, right? So
right. So thank you. I did not explain that. Here, when I'm doing when I'm requesting a get on this user file for its content, that is downloading into this response, file content response. It's not down. I'm not asking it to download it to my local home directory or anywhere in my directory. It's all of that download is going into file content response object. And with file content response, I can look at the headers and see, is it okay? Is it 200 or whatever? And I can get the content out of file content response. So yeah, everything's in memory here now.
Yeah, I just wanted that to be clear to people in terms of the file, what they're getting. They're getting the file, but then, as you said, they're accessing different portions within the file. That's it.
You're getting it, but you're getting it in memory.
Yeah. Okay. Thank you.
And so you can do anything with it, like this. I'm setting file content equal to the content of what I got back, and I can just do a Python len on that content because it's in memory, because it's in that variable, right? So I can do anything with it.
Yeah, great. Thank you.
No problem. Exactly. File content is file content response content. Okay. And so I want to show you something about sessions, is that we can invalidate the session that we have right now with that API token by, in fact, sending a delete request to this session for this CBrain API token. So you don't have to do this, but I'm going to do this, okay? Because I want to show that I can explicitly get rid of a session, okay? And that if I go back to NeuroHub and my account and new API token, that's a completely new API token, and that previous one can't be used, I believe. So here, for subsequent examples, I'm going to use this new API token. Okay? So, does that make sense? You don't have to do this, and your session will last for, I'm not sure, is it by default 24 hours? Yeah? I'm not sure how long the session and that the API token associated with that session sticks around. But if you explicitly want to say, I'm done with it, then I'm done with it. Now, I noticed that I went really, really slowly. So I'll go, should we have a break right now? And I'll go quickly through 2, and then Jacob will go through 3, and hopefully we'll get to 4. Okay? So thank you. 1 day, 24 hours is the validity of a token if you don't explicitly send a delete to the session. So I'm going to start up with groups and data providers. In this one, I'm going to try and go a bit faster. There's not a lot to it. It's just getting information about groups and data providers. But is that okay for everyone that we take a little bio break right now? Okay,
sure.
good.
So we say
that's a good idea, Darcy.
15 minutes,
and maybe allow for a few questions before we go to the break.
Oh, yes. So questions before we go to bio break. Please, questions.
If any.
So that's what I showed in this one, is you log out, you delete the session, you destroy the session by sending a delete request to base URL session. Okay? It sticks around for 24 hours, the session, which you may want, you may not want, right? Especially if, let's say, like in this context where I've been fast and loose with the API tokens and showing you API tokens. If you don't want to be fast and loose with API tokens and the visibility of them, right? Which I'm doing right now. I'm being very fast and loose with the visibility of my personal API token. Do a logout. Do this delete session. Okay? Any other questions about that?
Yes.
Oh, and yes, you can now, if you are finished with Notebook 1, if you got to this place and you got these numbers, okay, saying that you can actually stop this by shutting down kernel. So you can that was a left click on NeuroHub sessions files. You'll notice that the green light has gone away. So this is no longer an active kernel running on a resource, on a compute resource, taking up time. So you can explicitly close that. So yes, this logout session does not log you. This only logs you out from NeuroHub. This does not log you out from the notebook server. You have to explicitly do that yourself. Okay. So now the only thing that's running for me is NeuroHub groups and data providers. And so again, let's come back in 11 minutes. And I guess you can, I don't know, play some Justin Bieber to accompany yourself while you're doing whatever.
Okay, we'll be back at 3:15, so 10 minutes. Yeah, close. There we go. Thank you, Dorsey.
So there was I guess some discussion about how do we find out if our session is live, our session is good. And I think, do I do that? I do that in Notebook 2. Is just I post to session. Well, we'll get to that. So hope everybody's back. Hope everybody's good. Again, I'll go through this quickly. So at the top of your notebook, it's always a good idea to explicitly say what your requirements are, okay? What it is that you're using. And to try, even if it's already installed locally, which now it is, because remember in the previous notebook, we installed requests into the context in which these notebooks are being run. So if I run this, I should get back requirements already satisfied. Exactly whatever I expected, but still good to put this, okay? Now, if the import, we do have to do, because this is a different Python context. So we do explicitly have to import again in this different notebook, okay? We do explicitly have to set things like, where did I go? Like base URL and my Neuro API token, Okay, and you're going to have to do this too. So where it said paste NeuroHub API token here, either your new one or the old one if you haven't destroyed your session. Okay, so and let's try this. Now, this, we're just going to check on the session, check that I didn't, that I can get a session with this CBrain API token, and that everything's okay. Session is valid. My user ID, again, is 1308. So you should, again, see the same user ID. Okay? Should again be seeing the same user ID as in the previous notebook. Okay? So has everybody gotten to number one? Has everybody gotten to setting up their context in this new notebook? Looks like a lot of people have. Okay. Again, you should be getting, if you run all of these, you should up to here, you should get session is valid and you should get back your same user ID. And why did I use this? I guess I didn't have to do a post. I'm not sure. I guess I could have done a, why did I do a post? I did a post because I did a post. And it replied the thing. I guess I could have done a get there too. Yeah, so remember that get and post are the equivalents of what you're doing in your browser. What we're doing directly in the script here is equivalent to what's happening in the browser, but in this more structured way, in a way that we can see what's happening. Okay, so that's the beauty of this REST API, is that we can explicitly do what our the web app is doing behind the scenes for us. And that's always a good thing, to be able to tell that. Okay, so let's see what groups I'm part of. So everybody run in 2. And does everyone see this? Does everyone see everybody's?
Well, they should see a subset of that because you're using your account and your token.
You're exactly right. You should see thank you. You should see something like this. You should not see exactly this, but you should see a response. And specifically what you should see is an entry with the name Workshop Jan 2021 is what you should see. That is exactly what you should see. Okay. So here what I've done is I said, let's get the list of all the groups that I'm part of. Okay. Now, what is it that I could have put in here? Remember, I'm getting a list of groups. A list of groups. What I could have done, wait, where's show hide? Where's groups? Get groups. And I could have paged through the results. I could have said, please give me page 1 with 10 per page, 1,000 per page. I think 1,000 per page is the limit. And done a while true and only gotten out of that while true if I'd gotten an error or if I got to the end of the list. Here I did not do that, okay? Because I knew that I'm only part of a few groups. I'm not part of hundreds or thousands of groups, okay? Or even tens of groups. I'm just part of these groups. And specifically, you should only be part of, I think you should have a user group and a workshop Jan 2021. And I'm not sure what other group you should have in there. You have
there'll be other ones that correspond to CUMP data sets that are open, for example. So there should be about 5 that people see if they're using training accounts.
Okay. So, yeah. Because those are public groups. Those are public projects.
Exactly.
Okay. So, we can also get information for a specific group. Okay. If we know the group ID number, or like here, I'm just getting it from this list. I'm getting the info for the last ID. -1. So the last thing in that list, I'm getting its ID. Okay. And I'm getting info for it. Okay. Now, the thing is if I get info just for a group, it's the same info you're getting when you say list all groups. There's no difference between this info and this info, except this comes in a list. Okay. So you could have just gotten the list and said, okay, I've gotten the list. I'm going to get out of that JSON structure just the last entry. Same thing, same difference. Okay. Data providers. So, back to groups. I just want to make sure that we're all on groups, that groups work for everyone, that it seems that it did. People are saying that they saw 5 groups. And then remember, groups in the NeuroHub dashboard may be called are called projects. So groups are projects, really.
I'd like to add something there.
Sure, please.
Very quickly, for those who are familiar with Unix, the concept of a group on Unix is a set of users, and that's practically how it works in CBrain. A group is a set of users, and the web interface, just like Darcy said, never use the word group anywhere. It uses the word projects to describe this, but underneath it's really a group. And all the projects in CBrain and NeuroHub are sets of users. At that point, we associate the projects to any of the things that exist, and this determines who can access the thing. If you're a member of the project or a member of the group, then you have access to the thing.
Hey, good point. And, I'll get back to that to upload in a second. So, and notice that at least in the code here in the explanatory text, I'm using the word group, but I could have used the word project. Now I couldn't use that in the URLs that I'm sending gets and posts and puts to. But it's the same. So let's do the same, except for now we're going on to 3. We're going on to data providers. Okay. And what data providers do I have accessible to me? Okay. And here you should see, I'm just going to point out one that is relatively important. Where did it go? I was going to show off main store, but now I can't. I'm looking for the name.
It's ID 27.
There we go. Thank you. So, I want to show main store. Main store is the default store that you're going to that you can upload to and download from. There's a lot of storage in there. It's just the default provider, data provider. And yeah, so take note of that, of main store. And its ID is 27 and its ID will always be 27.
Maybe just a remark for in general, if you haven't heard, people should be aware what the terminology, what it means by data provider. But in the end, based on definitions, this could include people's spaces on Compute Canada. If that one gets set up, it's not by default set up. So it can be locations both basically located and hosted directly within NeuroHub and CBrain storage, for example, or elsewhere. So, but in this case here, that you're looking at specific ones that these training accounts have access to, or if you're using your own account, have already access to.
Exactly. So, for example, local Beluga is local storage on the Beluga resource, the Beluga cluster at Quebec at ETS. Okay. But main store is the one I wanted to point out. Is what you're usually going to be looking for. So let us, just for fun, what was 420? Is 420 something? I don't know why I put 420 in there. Because that's what's associated. I think 420 is the ID of what's associated with our work group. So it is not main store. It is, let me look through. Oh, no, not even that. It's the data provider for CONP, Simon. I don't know why I chose that. That's a good question. So I chose CONP, Simon, to look through that and see what files are available there. Okay, so there's 4 files, 3 files in one directory. And it's all the information you'd expect from file system stuff, right? Access time, create time, modify time, etc. All that information. Okay, so I'm browsing what's on a specific data provider from the list of data providers that I've gotten here. And let's not destroy the session. So, because let's keep this your current CBrain API token around for next ones. So I just wanted to say before I hand off to Jacob is there's 2 things I didn't do here. I didn't show you uploading a file. Wait. Fridge. I didn't show you uploading a file to a project or a data data provider. And I didn't show you attaching a new data provider, which you can do to NeuroHub. So you can add storage, your local storage to it. I did not show that because I didn't think there was a way to show that. But since thinking about it, because you've actually got a shell access on this virtual machine, on this virtual cluster, you've got a user space here. I could have actually done an SFTP into, or you could have set up as an SFTP into, for example, into this terminal, done the equivalent of an SSH. But I wasn't smart enough. I didn't think about that until until almost right now. So those are two things that we haven't done. So those I'm going to assign to you as homework. If you'd like to do some homework, please remember that we did not do uploading and we did not do setting up creating a new storage configuration. Okay, setting up a new data provider. Okay, so there is an uploading in the API. Let us go again to user files and post. This will upload. Okay, and it will upload to a particular data provider, etc. So this is useful. I did not show. Okay, and this data provider, register file, register. Registering a data provider, I did not do. Okay. So, because I both of them I didn't think I could do, because the upload, I thought, oh, if I give them the same file, they'll all just clobber each other on the same in the same thing. But again, just thought, well, what if I created a differently named file for everyone, or asked them to create a differently named file for each one? Okay, so I just wasn't smart enough to figure out how to do the examples well for those two. So please remember that.
I think that's fine. And there has been the first some talk how to show how to create a data provider. I think there will be more documentation and things of how to do that.
Exactly.
In one of the sessions that we discussed before, we talked about having that as a further add-on to the workshop to show people how to provide it.
Again, just so you know, it's not there because I wasn't smart enough to put it in this now, and because we've got Jacob coming up, who's going to talk about interesting, wait, where am I? Where did I go? Who's going to talk about NeuroHub applications. So because I've been ranting, going on and on, we probably wouldn't have had time for it too. So I'm going to leave I'm going to stop sharing and give over the presentation duties to Jacob for the notebook number 3, NeuroHub applications. I hope you're ready, Jacob. Throwing you into the fire. And
I just want to thank again Jacob for doing this. He's a student in my lab and in Tristan's lab, in Tristan Glattar's lab, and he's been wonderful helping us demonstrate those things.
Yes, and also I have to note that Jacob is a continent away from us. So if there are networking issues while he's presenting, do not be surprised, because
Colombian internet is suspect.
Networking is awful.
Okay, can everyone see my screen all right and can hear me all right?
Yeah, that looks good.
Okay, fantastic. So what you should go ahead and do for this is load up the 3rd notebook here, the NeuroHub's applications notebook, where I'm basically just going to be telling you about a few of the further applications of NeuroHub and some interesting little tips and tricks you can do, which could be useful for your research or your usage of this hub. I've got 3 main goals for this notebook. It's not a very long notebook. The first one is I want to show you how to download files using the API. So by downloading files from data providers or from groups, you can then run external scripts on them, which can be useful if you're developing those scripts. It can be useful for manual quality checking, or say for getting results from intermediate pipeline stages if you're automating work. So it's just good that you know how to get files off of NeuroHub if you need to by downloading them. And the second thing I wanted to show you is how to load these files into Python in such a way that common libraries, such as the ones that I'll be using here, such as Nibabel or Nibabel, however you say it, and Nylearn, can handle them. And the third thing I then want to show you is just how to do some basic processing in these libraries and just show you the workflow of how you would load up files in them after the download. And I've got some basic examples lined up, which is basically some visualization, extracting some voxel activity and in time series, and then a very just quick sort of toy example of an independent component analysis. So without further ado, I actually can't see the chat box here. I'm not fully sure how to get it up. So I'm not fully sure if I'll be able to see your messages, but I'll get going and hopefully I'll figure that out along the way. So I'm going to install pip requests, as was done in the previous notebooks, to get that. And then I'll have to reload the notebook. I'll have to restart the kernel so that the changes go into effect. Once that's been reloaded, then I can import all the libraries I'll be using. These are the same ones that Darcy has been showing you throughout this. So there's the request notebook, which we'll use to make API calls. There's the JSON notebook, which we'll use to just process the JSON formats that we'll be sending and receiving from the API calls. And then the get pass, just so that I can log in interactively. So the first thing I'm going to do is I'm going to log into NeuroHub through the API, as has been shown to you in most of these notebooks. So I'll enter my username and my password, which I hope I got right. Yeah, that looks about good. The second thing then I want to do is to show you how to download files through the NeuroHub API. So to do this, you'll need to know the file ID that you want to download. This can either be done by listing the files in the data provider through the API, as Darcy showed you. So if you have a data provider or a certain group, you can go to the second notebook here, and then you can use that for it to show you which user file IDs there are so you can download them. The other way you can do it is just simply through the web interface. There's a workshop January 2021 group, the project group, and then there will be files there. I've uploaded 2 files I'll be demonstrating on. And if you go to these files here, you can also just see what their file ID is, and it's that ID there. So you can either do that through the API or through the web interface. So I've preloaded the 2 file IDs we'll be using into this. The first one is just an anatomical T1 weighted scan. The second one is an fMRI nifty file. So we're going to download these files into our project directory. So wherever the notebook is located in the file system, the files will also, well, they should be downloaded there if everything goes as expected. So we'll have a string which has the file ID, and then we'll have the headers as shown here, which just show the metadata formats that we'll be using for our API call, and then we'll have the parameters. One of the 2 parameters is this string file ID for the file we want to download. The other parameter is the token from your session. So you need to be logged into your session to do this. Then to form the successful URL we'll be calling to download, we want to concatenate this address here. So portal.cbrain.mcgill.ca/user files. We'll want to concatenate that to our string for the file ID, and then concatenate content after that, so we can actually grab the content of the file. Then we make our call to this URL to download the file. It's important to allow redirect so that it can go through. If it is successful, what we want to do is we want to write these contents we grabbed to the file. So we are going to be, these 2 files, by the way, are simply some, they're just some brain scans from PreventAD, so nothing too fancy going on. And we want to grab those files, and then we want to write their content, which we just grabbed with the API call, to a file. So here we will simply choose the file name. I could have named this anything, and it would still work. You can name it hello.nii.gz. Just make sure you get the extension right. We want it to be in write mode, so we're actually writing to the files. And then we'll be writing the response of the call we just made, the API call, to the file. So if we just run that, it should take a little while, I'm guessing, especially with my Colombian internet connection, because it's not very quick. And then it should download the files. It says file downloaded here. That was actually surprisingly quick. I'm very impressed. And as we can see there, our file has been downloaded. We're now going to go ahead and do the exact same thing for our fMRI file. So the thing that we just downloaded was the anatomical scan. Now we're just going to grab an fMRI file, and it's the exact same process. So I'm not going to repeat it. We've just changed the string for the file ID. That's all we've done. So I'm going to go ahead, and I'm also going to run that. And it's a little larger, but my internet seems to be in tip-top condition, so hopefully it won't take too long. Okay, I'm trying to... Okay, yeah, there's the chat window. Well, I guess I'll get to the sysexecutable part in a second or two. We'll figure that out as we go. And thanks for showing me how to use the chat there, Serge. Should have figured that out. So yeah, we've got the two files downloaded. Has everyone been able to follow until this moment and get their files downloaded? Okay, fantastic. I'm seeing someone has raised their hand. Someone said, so far, so good on my end. So if two people could do it, I'll assume this is going fine. But I'll wait a tiny bit more. Okay, great. Okay, cool. So we've successfully been able to download the files, I take it, which is excellent. So the next thing we want to do is we're going to do some work with these files we downloaded. As I said, you might not always be able to run the things you want to run on CBrain, or you might just want to be testing out your own script on files that you got from a data provider that's hooked up to NeuroHub. So you might want to just run things by yourself. So the examples I'm using here are pretty much nabbed from the NiLearn examples. So I've just changed them a little bit so that instead of working with the integrated NiLearn datasets, they are working with these files we just downloaded. So to do that, we'll have to install two very popular libraries. The first one is NiBabel, which we will use to load the brain scans. And then the second one is NiLearn, where we can run some learning algorithms and do visualizations and that sort of stuff. So we're going to run this and hopefully install everything. I suspect it might take a little time. Okay, so this seems to have finished. Has everyone managed to install these files?
Just a question, Jacob, sorry, I think it was Gabriel that we mentioned about the matplotlib missing. Was that something that needed to be added here, or sorry, was already included?
It is perhaps indeed missing, but I think that's a little further on.
That's further along, okay.
A couple of cells down, or maybe it's not.
Okay,
I'm not sure. So far, we'll see. If I get, I'm running it at the same time with everyone else. So if I get the error,
exactly. Yeah.
Okay. Well, if we are indeed lacking the matplotlib thing, then thank you very much, Gabriel, for pointing that out. That is indeed my bad, and we should probably add that there and avoid any issues in the future cells. So what I've simply added there is Gabriel's already put it in the chat, but I will put it again. So thanks you very much. Oh, I didn't mean to write that just to Sergey. Send chat to everyone. So maybe add that to this cell or any cell and then run that. Okay. So I suspect after that is done, we'll have to restart the kernel so that all these installed packages go into effect. So I'm going to restart it.
In this case, sorry to interrupt, you may not have to restart the kernel because matplotlib is one of those weird dependencies here that you're not explicitly using within the Python notebook context. It's something that what you're using within the notebook context uses matlib itself. So I'm unsure that you have to restart.
Well, give it a go, and if it gives you a module not found error, then you probably need to restart it, I guess. And if not, then it's probably fine. So yeah, I'm going to go ahead and assume people have been able to download this well. It ran okay without the kernel restart. Yes, +1. Thank you for using the chat and letting me know. So I'm going to go ahead and import both of these packages. As I mentioned before, NI-Babel is what we will be using to load up the brain scans and actually have them in a format that then NiLearn can understand. And then NiLearn I will be using in this example for visualization, but further on in the notebook for a whole bunch of other things. So now that we've got these two files downloaded, we've got our packages installed, we want to load these files into our notebook. So the first file to load will be our T1 scan. So I'm just referring to it by its file name. I don't have to worry about paths because it's being downloaded into the same directory as where the script is. And I'll be using then, well, NI-Babel to load this file, then what I'll be doing after that is just printing the shape of the file. And you'll know you've loaded it well because it should be a 3D shape. It's just an anatomical scan, so we'll have 3 dimensions to it for the volume. The second file that I'll be loading is this file here, which is the fMRI file. And the fMRI file should have a 4D shape because it will also have the time dimension showing the changes in time for the volume. Then after that, what will be happening is I'll be showing 2 different ways of visualizing these brain scans. So the first one is just the general image plotting function of NiLearn, which you can use to plot any image, really, but it gives you a more colored plot. And then the second one is the anatomical plotting function, which will give you a more black and white plot. So I'll run that. As you can see, our T1 file, the anatomical scan, has 3 dimensions, and the fMRI brain scan file has 4 dimensions, and it takes a while to plot these things, but it does indeed plot them. As you can see, the visualization is there in slices. So I hope everyone has been able to run these visualizations themselves of the 2 files we've downloaded.
Sorry, Jeff, I have just one question, if you don't mind.
Yeah.
The step before that, step 20, when I try to run that one, it says no module name PY test.
No module name PY test.
Exactly, yeah.
That's an interesting one.
That's strange. It could be that. So PyTest, you know that PyTest is the testing environment that has been used by both NI-Babel and NiLearn. And I wonder if it's a question of, actually, I'm not sure, Vlad. If you,
I'm not fully sure.
If you sent me the thing, we can maybe look at it.
Yeah, because the step after that, I cannot do any plotting. I can get the coordinates, so the 3-dimensional coordinates for the structural image and the 4-dimensional one, but I cannot do any plotting.
Did you run this extra little install matplotlib command that I've missed in the original notebook? I added that just now after Gabriel pointed it out.
No, actually, so.
Yeah,
okay.
That's the problem. Yeah,
and you can just append it to the other one if you want as well. So.
Okay, so if you can you copy and put in the chat, please, so I can.
I copied it in the chat a little while back, but I'll copy it again.
Oh, okay, yeah, I just found it. Okay,
I've sent it again.
Thank you very much.
No worries. Hopefully it works. Fingers crossed. Let us know.
Yeah, I'm just gonna try it right now. So I should add it before the import.
Yes, before the import. You just need to run it before the import.
Vlad, it's just installing the package matplotlib. Matplotlib is actually a dependency of SciPy, which is itself a dependency of Nylern. But if you want to access matplotlib directly, you're better off importing it. You have to import it.
Okay. Thank you.
Yeah. So if that seems fine to everyone, I'll probably move on. I'll take silence as a yes in this case. So after we've done our visualizations, the next thing we might want to do is to smooth our images. So in the case of our anatomical scan, we might want to smooth the image to remove noise from it before we do further processing operations. And basically all this does here, when we call the smooth image package from Nylern, is it will apply a Gaussian filter along the volume. And we will have, here we can see that the first parameter references the anatomical scan, which we just imported. And then the second parameter here specifies the amount of smoothing in millimeters. So the higher that number is, the more blurry your picture will look. And then we will plot it afterwards, and we should be able to see the difference between what we previously plotted and what we plotted now. So there's the scan. As you can see, if you compare it to this image up here, it is indeed slightly more blurred out. And that is the effect of the smoothing. After this, that was all with the anatomical scan, the T1 scan. We might also want to visualize the fMRI scan. So we can do this by importing mean image from the Nylern image package. And what this does is it basically, since the fMRI is many 3D volumes over time, it will then just compute the images over the time, the average of the images over the time dimension, and then we can plot that. And they have a special thing to plot this called plot EPI, which will, and then we will be able to see what the mean plot of the fMRI visualization is. So there's that. Has everyone been able to visualize the anatomical and fMRI scans? Yes, looking good. Thank you. Excellent. Good stuff. Okay, so the next thing we might want to do after visualizations is we might want to say extract voxel activity from a particular voxel in our scan. And we might want to see over time how the activity of that voxel varies. So I'm going to show you how to do that next. The first step to do this is to extract the brain mask. So the brain mask is simply, imagine a hollow 3D volume representing where that object in space would have been. So it's just going to be a thing shaped like the brain in our 3D volume. So to do that from the nylon, we'll once again we'll import the compute API mask from their masking package. Then we will compute from the file which we uploaded from the fMRI file. We will compute the API mask using this compute API mask function. And then we're going to visualize it as a region of interest. So from the nylon plotting library, we're going to then just use the plot ROI, which is yet another visualization method. And then we need to provide both the mask and the mean image to be able to plot one on top of the other one. And if this happens successfully, and you see a nice blue mask, which is approximately the shape of the brain which you introduced, as you can see, this is similar to that, and this is similar to that, then you'll know it has computed the mask well. And to visualizing, you can easily tell if it has gone through with this. After you've extracted the brain mask, then what we'll want to do is we'll want to apply this mask to the brain scan file, to the actual readings from every voxel, to extract the corresponding time series. So once again, from the nylon masking library, we're going to import apply mask, and then we'll have the apply mask function where we provide the actual file, the nifty file of the fMRI, and our mask. And this will read the time series, and it will extract the signal from the file, and it will give us an output in the form time points voxels. Then we'll import matplotlib, which will allow us to plot this. And what we're going to do is we're going to choose the first 150 time points. So we can see from this notation that we're going from time point 0 to 150, and then from 0 to 2. So we'll be plotting the first 150 time points for the first 2 voxels. On the x-axis, we will be able to see time, and then on the y-axis, we'll be able to see the intensity, to see how the output of each of these voxels changes over the time of the scan. And then when we do show, we should be able to visualize this as a graph. So we can see one of the voxels over time is expressed in orange, the other one is in blue. And yeah, we can see how through whatever task these people were given when they were scanned, these particular voxels change. If you wanted to change to a different voxel or different amount of voxels, you'd change this here, this too. And if you wanted more or less time points or different time points, a different subsection of the time points, you change this 150. So has everyone been able to produce that graph successfully? Yes, yep, yes. Awesome. Good stuff. So then the next thing I wanted to show you how to do is given, say, this fMRI file, we might want to do an independent component analysis of it. So an independent component analysis, very briefly, even though the objective of this is just more to show how it's done than to go into what it actually is just a signal processing method to separate independent sources, which are linearly mixed in several sensors. So from the several sensors of an fMRI scan, we'll want to see which signals are linear combinations of each other and can then be separated. And this is a special case of blind source separation, where we don't know what the sources are, but we want to separate them and be able to see all of them individually. In the context of a brain scan, this is cool because it can tell us to what degree each component contributes to the observed signal in the fMRI. And packages like Nylearn and sklearn make this extremely easy to do. So this is more of a toy example than anything to show you how it is done. But from Nylearn input data, we will then import nifty masker. And this is yet another way to generate a 3D mask, but this time it also removes the background from the mask. We also have an amount of smoothing we can provide. So here I've chosen 8mm smoothing. These memory options are simply you'll see that a file will appear here which contains the cache, so you don't have to recompute this in the future. I didn't take those out. And you choose the mask strategy. This is an EPI, so EPI. And then we will simply fit the transform to the fMRI scan. So we'll run that. Seems to run well. Then from sklearn, which should load fine, even though we haven't imported it as it is within Nylon, we will import the fast ICA, which is a method which, as its name suggests, does a fast independent component analysis. You can specify the number of components you wish to separate from the signal. So in this case, I chose 10. And then there's a random state, but we don't have to worry about that. That's more to do with distribution of these components. And then we'll want to fit our transform, as we did here, to the mask data. So we'll also want to fit our transform to the mask. After we have fitted the transform to the mask, what we want to do is we want to normalize all of the estimated components. This is so that we can then binarize it and apply a threshold such that we will only see the components above a certain threshold, which are the ones we are more secure in or have a stronger signal that we're interested in. So as you can see here, we're importing NumPy, and if the components are below 0.8 after normalization, then we are simply setting them to 0. So we don't want to see them when we visualize them. Everything that is above will remain with its normal value, anything that's above that threshold, and thus we'll be able to see it when we visualize it. Finally, what we will do is we will do an inverse transform to go back to the sensor space or the full 3D representation of the fMRI scan, so that we can then see what these components would actually look like when overlaid on top of the brain scan. So we're going to run that too. And as you can tell, it runs fast, hence the name Fast ICA. Next, from the Nylon, well, we want to visualize this. We want to actually see the components that we separated in our blind source separation attempt to see the different components of this fMRI. So we're just going to go ahead and plot what we did. And we're basically just going to use the mean image of the fMRI scan that we calculated previously. We're going to use that mean image as our background, and then on top of it, we're going to plot the binarized components. And this should hopefully show us the 10 strongest independent components that we were able to separate. So as we can see, it has done that successfully. And we now have a little plot showing us all of these components from the ICA. So has everyone been able to do that well? Yes, yes. Yay! Thanks, Darcy. Appreciate the enthusiasm. Yes, yes. Awesome. Well, that was the end of this notebook, but I just think it had a good few tips and tricks. Then basically the important things, the messages that I'd like you to take away from this is that you can download files from NeuroHub, and it will show you how to do them and how to save those files, which can sometimes be tricky if people are not well versed in Python. So you have an example there of how to do it. Then how to load these files into Python in such a way that then you can use the large ecosystem of available neuroimaging tools to actually do some work and process these files. And then you have just a couple of nice toy examples showing you how you can call functions on them and how you can do some ICA or extract some voxel activity, which is pretty useful and pretty interesting. So if that all works, I'm quite happy. And I think that's the end of this notebook. So perhaps in the remaining 20 minutes, we can go back to the last notebook. And that's it. Thanks.
Yay. Any questions, I guess, for that, for Jacob on that?
No question for me, but a big thank.
That I think there's nothing better to motivate why you should you can and you should do this is with an example exactly like that, because yeah.
I mean,
it's
as
nice.
Jacob
It's
said,
nice graphs.
as Jacob said, those are toy examples. Like you usually maybe not want to smooth an anatomical image or things like that. It's just like to show how to do it.
So I'm going to be very brief with 4. I'm going to try and go over this fast so that I can give Brian some time at the end. Brian and JB, I guess.
Well, I'll just need like 30 seconds at the end just to share a link with people. So don't worry about my time.
So I'm going to go. I'm still going to go quickly. What I'm going to say, and what somebody reminded me of. Thank you, whoever reminded me that. Remember, you can get to all of these examples and use the code yourself, or if you notice that something maybe was not great in these examples, you can do a pull request and say, please do this, or please put an issue against it and say, please include this in that notebook, blah, blah, blah. So remember that all these examples are at, and I'm pasting it in the chat, are there. So for later use, for later copy and pasting of little snippets that you can use, go there later on. And please do suggest stuff that maybe we haven't shown all that well. So another thing I won't say that yet. Okay. So just back to it, import, and is this right? No, it's wrong. Where did I put my latest API token? I have no idea. My accounts. Oh, let's just make a new one. Okay, bump. Take that, copy and paste in here. So I'm taking the API token instead of doing username password, but you could do username password, obviously. Just to remind you, we're using API token. And let's just check that we have a valid session very quickly. It is valid, and my user ID is 1308. Again, just given that API token, this is what I get back, and that makes sense. So I want to quickly talk about, so yes, you can download files locally and use exactly like Jacob said. You can use the panoply of stuff that's out there for Python to do a lot of stuff locally. But there's also long-running pipelines that you'll want to run on NeuroHub /CBrain and on the Québec resources, those big clusters. You'll want to start a job, and you'll want it to run there and let it run for a good long time, right? Minutes, hours, maybe not days, but days-ish, and a large number of jobs, a large number of pipelines you may want to do. So we can obviously do that from the web API or from the website, but let's look at how we do it programmatically. And first of all, what tool configs are out there? And let's just list them. And here, I'm not I do page through. I do paging. I do a while true and only break out of it if there's an error or if I'm at the end. Okay, so there are 153 tool configs. It's a lot of tool configs. And tool configs are pipelines. They're executables that can be attached to particular runtime environments, to particular bureaus. So the important thing to look at within these tool configs is what is the tool ID and the bureau ID? What is that pair of things in those tool configs? Because that's going to tell you what's the tool and where it can be run. Okay, that's why we want these. Now, independently, I could get a list of just tools and a list of bureaus, but it's not quite as useful, at least in this context, where I want to see what is runnable, what is pipelinable, what tool is runnable in what context. So here, that's why I'm listing tool configs, not just tools and not just bureaus. Okay, now there's quite a few of these, so let's go through these. And don't worry about all of those. What I'm going to do is I'm going to filter through those 153 and look for something that in its description mentions FSL. Ooh, and there's a few of them. Ooh, there is a few of them. So you're going to look through and it's hard to choose from them. What pipeline am I going to use? So I am arbitrarily going to say, well, not arbitrarily. This was arranged ahead of time. I'm going to say I'm going to use 721 out of this. I'm going to use this one. Okay, and let's see actually what the tool info and the bureau info associated with this pipeline, with this tool config is. So let's go down. Let's look at the info just for that tool config. So I've filtered out of that long thing just what's happening with the tool config. Now let's look just for tool 51. So I'm getting a list of tools and I am filtering through them just to get ones where the ID is equal to 51. So let's look at that. Okay, it's FSL first. And that's actually what I wanted. So I want something that runs FSL first. Let us get the bureau, specific bureau, and bureau 39. Remember, 721, that pipeline has tool 51 FSL first, and on the bureau that's running on converter 2, provided by CBrain, 24 cores, blah, 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 for quick conversion tasks, okay? And quick, fast scientific tasks. Okay, that's good to know. So I'm going to be rerunning this tool, FSL first, on this bureau, which is the runtime environment, which is the executor of executors that are there. So remember, we can associate data providers with a project, and administratively, we can associate bureaus with NeuroHub and CBrain. Those are two distinct, so storage and execution environments are two distinct things that can be remote resources that can be associated with NeuroHub and with CBrain. Okay, those are two remote things that we worry about that aren't inherent to the CBrain system itself that help us along. Okay, so paste my user ID. My user ID is, again, it's 1308, right? Let's go back up to here. Yes, it's 1308. And actually, instead of pasting, I could have programmatically gotten that user ID. So I could have just put in the that as a parameter, as a variable, but let's paste our own thing. And no, we're not going to be using login name or etc. Our username. Internally within NeuroHub and within CBrain, everything has an ID. Users have IDs, files have IDs, file providers have IDs, bureaus have IDs, groups have IDs. That's how we natively talk about it within the API. We don't talk about and we don't look at or look up things by the username or the tool name or whatever. That the tool name is only in that info that we just looked at, like this description stuff. It's always dealing with the native IDs. Okay. So let's submit a task, and hopefully, so remember that we chose 721 out of a hat. Really, we didn't. It's something that should work, and it should work on the file ID that Jacob was just using as input to his things. So we're pointing to the file ID on the data provider and saying, you task, you pipeline, use that directly and stage it to the bureau, to the appropriate bureaus, right? We're saying this file ID and we're using this data provider ID. Again, data provider ID 27 is main store. That's what we're giving to this. And the specific task specification has some general things, right? Data provider ID, user ID, tool, config ID that we've just set here. But it also has, specific to the tool, is this this thing within the description, params. And this is specific to the tool, and you're going to have to look up what does the tool actually require. Okay, so these are general. This is for the tool itself, and the tool in question is that FSL fast. Okay. Now we're going to post this task, and let's see what happens. No, what did I do wrong? User IDs. These parameters depend on.
It's the file ID, and it should be file underscore ID, I think.
Thank you. Thank you. So change that to file underscore ID. There we go. So we get back some information. The important part of this is status new. This is a newly created task, a newly created instantiated pipeline that's running. And there should be the bureau. It's running on 39 as we expected, etc. So it's running now. How do we check what the status? How do we check when it's finished? Well, we ask, and again, response status code. What am I doing wrong? Task status. How did that get through? Task status. So change that response to task status. And you'll see that right now, again, the important part of this is status on CPU. So hopefully you've gotten to this point and you're seeing on CPU. You will not see completed for another 6 minutes. So if I keep rerunning this, so if I rerun this asking what the status is, and unfortunately there's no other way, is we have to keep polling to ask, okay? Or if you don't want to do that programmatically, if you want to, if you just want a visual view of that and there aren't too many things that you've started, go back to the NeuroHub and just wait for this page to refresh. It's showing on CPU. At some point, again, in about 6 minutes, it should change to completed. So this is one thing that letting the web app do the status for you is probably the right thing to do, right? But if you want it, because polling, don't poll that often. Don't rerun this get status too often, right? Depending on what you expect that task to do, what you expect that pipeline to do. So I know offhand that this is going to take about 8 minutes. So maybe I put this in a loop to check every minute. Okay. There you go. So that's all I have to say. I just want one more thing to say is, we are at Calcul Quebec. We are working on getting a nice, stable interface like this up all the time on Beluga for you guys to use if you have Compute Canada logins. Okay, and we have a few things planned. Hopefully, notebooks. You won't just be able to start Python notebooks on Beluga. Hopefully our notebooks, our studio, will be another option here under notebooks. And anything that that we get enough asks for. I think there's been an ask for MATLAB, and I think we have that. We maybe can do that, but it actually may be better to do Octave. I'm unsure about that. But ask for functionality, don't bug Calcul Quebec, but, talk to them once in a while and say, especially if you're a Compute Canada user, and say, hey, what's happening with the Jupyter Hub that's on Beluga? And hopefully we can help you. That's all I have to say.
Great, thanks, Darcy. And just my further point to add here, I won't go into any more details, but just to say that there's also coming up, people might have heard of also, maybe I'll ping Samir to say a word if he wants to, but NeuroLibre, for example, where notebooks will be, we're planning on incorporating connectivity to allow connection between the NeuroHub side and what's going to be, what is available on NeuroLibre for running notebooks there as well. So that's in the roadmap as well.
Yep, that's a different.
Yeah.
It's a different model, but it's very related.
Exactly.
Yeah, just in a few seconds, maybe just to highlight that a little bit more. We've completed the infrastructure for at least the prototyping of this initiative, which is basically to allow for the average scientist researcher to publish more openly their data as well as their tools and scripts in a very similar way to the demo today, where you saw the use of various notebook features. And so we want to make that kind of functionality available to everyone. So in 2021, you're going to be seeing some of these new kinds of tools popping up and working with NeuroHub and all the underlying technology. So if anyone has more questions, they can ask or stay tuned.
There's actually it's a good point that if you have more questions or if you have a suggestion, things like that, I really encourage you to either go directly on the GitHub repos, as Darcy was saying, but also send a quick email to the NeuroHub support. I think we really need the feedback and see where are the pain points that we can eliminate.
Sure, and I'll just wrap up because we're getting right now to 4:28. So we've gone through pretty much right on time. So I think hopefully with everyone today, we've seen through the different exercises and the trials that you've gone through, the different learning objectives that were there. I'll just wrap up by pointing out some main links you should have seen already, but we have our main neurohub.ca, which links to all our documentation, also to getting into the portal, as well as pointers to the GitHub, specifically through the documentation to the GitHub repo that was mentioned in the chat by Darcy, and was also already talked about. If there's any questions, please send us an email at our support.neurohub.ca. Last thing I'm going to do and ask people to do, I really appreciate everyone sticking around. I was counting before, I could see around 37 participants here. Please go through, and we have a little short survey that we'd like to get your feedback. We're going to send this around directly as well by email, but I'm going to post it directly in the chat here as well. If you could just take a few minutes to give us your feedback specific to the workshop, and there's also an opportunity for us to get some feedback from you if there's things that you would also like to hear more about and also learn more about and see things within NeuroHub itself. This is through the survey page. You can complete that form to both give commentary specifically about the workshop today, the exercises, how things were organized and how things were run, but as well as, like I said, things that you'd like to hear more about and things you would like to see incorporated into both the training as well as the platform itself. That's a great place to do it.
Some of that feedback will be taken into account for future workshops. We already have other coming up. So if you're interested in things like querying, or maybe down the line, even more specific publishing type of aspects, but whatever else you think is important, we can easily put that into the agenda. So feel free to it only takes a couple of minutes, but it would be really good if you could enter that information in the survey.
And to incentivize, I'll be looking probably to selecting one respondent for some form of, I would say, reward, if you will. I won't go into details, but we'll select a response. So I encourage you to take a look at submitting your feedback to the workshop for today. And as Samir said, giving your wish list, if you will, for other things to be presented in the future. With that, we are on 4:30 now. I'd like to leave.
Is independent of what you say in the feedback.
Pardon me?
The reward is independent of what we
exactly. Yes. Reward. But we'll find a way in this climate of not being in an in-person workshop of rewarding somebody who provides their constructive feedback. Let's put it that way. Let's take a couple of minutes. I know there's people, it's been a long afternoon for people, but if there are any questions or that people would like to bring up in the time that we have, that would be great. You can be in the chat or verbalize it while we have people on the line. Okay, well, if not, I don't see anything popping. Maybe people are typing, but I'll give we'll stick around for about 5 more minutes. But I'd like to pass along my thanks for you, for, like I said, to everyone for sticking it out and for participating. And I really, like I said, would appreciate your feedback so we can try and make sure that we tailor as best as possible the learning experience for you guys, and as well as understanding what this can provide to you for your research. So thanks very much. And I'd like to express a big thanks to Darcy, to Jacob, to Pierre, and all the helpers who've come along and helping everything out today. I think this has gone well, and I like I said, thanks to you for doing all this.
And thank you, Brian, for organizing.
Yeah. Anyway, like I said, we'll stick around for maybe 5 more minutes, at least the helpers. If there's anyone who wants, maybe if they have a burning question they don't want to say, but we'll stick around for 5 more minutes. we watch people drop off. Well done overall. Thank you. Let's see who's still on the line.
Yeah,
I hope. Sorry.
I was saying that I have nothing to say.
Oh, good. I think that's a good
Nothing to say about nothing to say.
I hope it's a good sign.
I see. Yeah. I'm just seeing if there's others who.
Oh, if you're wondering, Darcy, that was very good. In fact, both of you, Darcy and Jacob, you did a very good job.
Thank you.
Thanks.
I agree, and also it was really good to have Pierre kind of answering questions on the chat while you were talking, because it's hard to multitask that kind of stuff. So that was very helpful.
Yeah,
exactly.
That's why we wanted to have the helpers particularly. Right? So.
Exactly. Thank you very much, Pierre. And exactly like Jacob was saying when he went into share screen, when you're in share screen on Zoom, you can't as easily see the participant list and the chat list when you're sharing screen.
Yeah, here's a suggestion for that. I've actually had to have it pop out the chat window and pop out the participant list, and I keep those to the side. And so that worked for the share screen if I popped it out. If I didn't, then exactly as he said, I lose it all. Right?
Yep.
Okay. So we still have Raoul, we still have Ming Li. Whoops. Let me get out. Douglas, Morgan, and George. Any questions from anyone who's still here? Oh, I see Pierre, you're saying something. I don't know if you're saying it though, Pierre. I can't hear you.
Never mind, it's not important.
There's a question from Vladimir. So next time, how to run statistical analysis on a large data set. And Raul asks, how easy is it to incorporate a new pipeline to NeuroHub?
Maybe let's start with one of those questions. Let's start with the second one first. From Raul in terms of this singularity in the NeuroHub. Pierre, do you want to say a few words?
I think that's a perfect Pierre question.
Which question do you want me to answer?
The one about incorporating a new pipeline into NeuroHub. Should it be in Singularity or Docker?
There's two ways. Docker, just you can develop on Docker, but when deploying, we're just going to take the Docker image and convert it to a Singularity image anyway. So there's a straightforward way of doing this. The only way to actually run a pipeline in a container on the supercomputers is with Singularity. They don't support Docker anyway. But you can still develop the pipeline in Docker. That's totally acceptable. It's the easiest way of doing it, in fact, for us, for deploying a pipeline, because once you have an image, it's very easy to move that Singularity image from one cluster to the other to deploy it on multiple clusters. In fact, we deploy it just once, and CBrain automatically synchronizes it on all the clusters, and it makes the tool immediately available everywhere. It's the easiest way. So provide a Singularity container that works, and it's super easy for us to just deploy it. Along with the Singularity container comes what's called a boutiques descriptor. It's basically just a tiny file that CBrain reads to know what the container does, what kind of parameters it takes, and CBrain out of that, it generates a form and everything. So that's the easiest and simplest way of doing this. The other way is the traditional way, where we deploy the tool on the supercomputer cluster and we write the tools integration into CBrain manually. This is way more flexible and it can do way more things than the Singularity way. But if you can do it with the Singularity way, then do it. Otherwise, we use the traditional way for more complex scenarios, scenarios where you have pipelines with dependencies or very complex forms that are dynamic, which is not supported in boutiques. That kind of stuff. We do it with the traditional way. For doing that, in that case, it's the CBrain developers that will do it for you. We have to schedule something to do that because typically it's not easy for external people to learn all the CBrain API to how to code a CBrain task in CBrain using the traditional way. It's a lot of programmer work that's required.
That's why they mentioned the boutiques element side that you talked about.
Yes, boutiques simplifies everything because boutiques, the developer or the tool developer can just package it and then provide us the boutiques descriptor, or we can even write the boutiques descriptor ourselves, and that makes things very, very easy to deploy. Vlad's question was
Just
how to run
before-
Or more a
statistical-
suggestion, I think, for next time for training is, I think, what you're referring to, Vladimir.
Vlad?
Sorry, I guess, Vladimir, you were more a suggestion for next time for training. Is that?
Oh,
Oh,
so my question was how to do statistical analysis.
the sound is bad, Vladimir.
statistical
So
analysis.
how about running statistical analysis? You mean for the training, or how we would do it in the context of using what we showed today?
Well, using your environment, using NeuroHub.
So
Like,
one thing you could do, Vlad, once, let's say you have a huge CSV file or something of that kind, you could certainly use the, basically use a script and pandas and test your analysis first on a sub part of the CSV and then run it as a,
I'm not talking about CSV files. I'm talking about images.
Oh, images. Then, but before any statistical analysis, you probably want to extract the features, right? Or do you want to do?
Let's say voxel-based analysis.
So why don't you,
Sorry, I couldn't hear.
the same way that you would normally do it, only leveraging all of the functionality you saw today, right? So say you had a bunch of R scripts to run VBM, for example. I mean, you could run those en masse on the servers, but the things that would be facilitated for you would be that you would have a notebook to be able to document and do this quickly. You would be able to do this, in a more structured way. You'd be able to share your results easier. So it's not that VBM, by itself is necessarily any better if you do it on NeuroHub or not, but you would benefit from all the additional parts.
Well, okay. Let's see how you do it.
No, but I mean, that's a fair point. We could definitely have at a future tutorial, actually doing it. We can just literally go and show people how to do it within this context and this environment. And I think that would be a pretty good tutorial. So we could take that under advisement. Absolutely.
Yeah, thanks, Vladimir.
But Vlad, your question is more a generic question, right? It's not really a specifically statistical analysis. It's how do you
my question is, let's say you have a small study of, let's say, a couple of hundred subjects, and you want to run something on 100 files, but you have to transfer them all to somewhere and run some tool on them all together, right?
Right. If you want to use Compute Canada, if you want to use Calcul Quebec, you do have to transfer those files on the servers there.
But you can also connect if you have a server in the lab, for example, you can configure that with being a data provider and also as a resource even within NeuroHub. So that can be then the source location.
What I was going to say is that the location of the file themselves is the key to optimizing this and making this fast. So within NeuroHub, if you put the files not on main store or NeuroHub store, but you put this on one of the data providers that is on one of the supercomputers, this means then that the data set is now local. At that point, if you run your analysis, your dataset analysis on Beluga, then the files will be accessed directly without having to copy anything. It will simply be that the batch or the jobs that you launch on Beluga will access the files directly on file system right there. And this can be done using the data providers that are offered as a service by NeuroHub and CBrain, or using one of your own data providers that you configured yourself. It's basically just a directory that you've selected on Beluga. You put your file there. Then you run the tool and the tool will access the file directly without any copying necessary. So it's on a case by case basis, but basically the concept is that make the files close to where they're processed and then you don't have to copy. And
even in the last training, we showed how people can run over, for example, we're running Civet, for example, you would be able to give, I think it was a Civet pipeline that was shown, okay, we have different input files and you could actually automate it so you don't have to run through the command line. You can just have it through the CBrain side of things, having it execute across the full set of data within your 200 subjects, for example.
And the last thing to add, maybe Vlad, for your specific case, is that you can have your data in a data provider on Compute Canada and launch some script directly on those things. Like you can have your own scripts and your own Slum scripts and whatever and launch those things directly as well. That's why we were saying that there's a bunch of possible things depending on what is the use case for you.
But even over multiple subjects, we have those examples, and we can point to those, and we can help you with understand how to map that to your needs, for example, and how would that map to your case, for example.
Well, if you have a sample with a couple of hundred subjects that you use CBrain on, why don't you run statistical analysis afterwards on this data set?
Yeah, I don't know what you mean by statistical analysis. If it's there are two different basic processes. One, the ones that can be parallelized or can be distributed, and you can launch on each sample or each participant at a time. And the ones that need all the data to be actually run. So let's say you want to do, I don't know, like a linear regression across voxels, across brain regions, for instance. So those guys, they can extract those brain regions and then launch, but they need all the samples at the same time. So those are the two kind of like different things. Or if you want to, let's say, do what Jacob was demonstrating, you want to launch an ICA and get the ICA across, like your 300 subjects. That requires all the data to be there. So that's there you will get the limitation of the, memory limitation and things like on Compute Canada, but that's a different limitation. It's not specifically a NeuroHub or CBrain limitation.
Okay. Well, thank you.
Welcome.
Thanks, Vladimir.